Hey everyone, welcome to Manual Many-to-Manys. So in this one, this is really like kind of like an intro to data transformations. Hopefully it gives you some ideas for how you can handle problems like this because they show up a lot in programming. Um, you can deal with this problem and things like it in the future. So let's talk about what it is. So we let's say we have two kind of related things. So they might come back from the database like, let's do owners and dogs. Familiar with that problem. So I might have an ID and a name and do another one. Okay, so here's our owners. And we have dogs. Bixby and Mesa. And then we have like ownerships. So that'll be our join table. That's going to be something like owner ID, dog ID. And so every instance of someone owning a dog shows up here. So Kyle owns Mesa and Bixby. And Elise owns just Mesa. Oops. So let's say we had all this data. This is just a select all out of these tables from the database. The thing that we ultimately want is to have those show up as like some kind of nested thing in here where it's Kyle is ID1, name is Kyle, and then has like a dogs array that has each of the dogs in there. Or I might want to do it the other way around where I have ID1, name is Bixby, owners, and then that's an array of all the owners objects. So I've like made that relationship. How would I do such a thing? Given all that data, what logic would I write that would jam all those things together?
Normally, like in your controllers, you would have like an include, right? And you can
Nope,
include
but
the,
we're in Dribble script.
oh, I don't know.
Can't use active record. We got to just write regular old logic.
Would you use a conditional?
You might have to use all kinds of different things. Might have to use loops, might have to use conditionals. We have enumerables. We have all kinds of different ways we could do that. So here's what I want to do. I'm going to write some tests for this, and then I'm going to give you all a repo to clone down. I want to see if you can make the test pass. We'll give you a little bit of time, then we can talk about maybe how to approach some of it, and then maybe I give you a little bit more time, then we'll take a look at the answer. So this will also hopefully give you a little bit of an idea of how testing works too. It's not nearly as scary as it might seem on the surface. So let's go manual, many to many. Okay, so I'm going to make a new node project. I'm going to install Jest, it's a testing framework. I am going to make this a Git repository. I am going to make an index.js file. I'm going to git ignore no modules, like that. And I'm going to make a tests directory. Can't remember if that has to be singular. We'll see. We'll see in a sec. Call this transformation, or I'll call it relate. Relate.spec.js. And I'm going to make a testing command. It'll be just. Cool, found it. All right, so in our spec for this, just same thing we just had. Make owners as an array of objects. We'll make dogs as an array of dogs. And we'll make ownerships like owner ID 1, dog ID 1. Oops. All right, so I have all those in there. The test for this is going to be describe relate. How do I know that relate works? Well, I'm going to, it relates dogs with owners. And so we're going to import in a function from the index.js thing. It's be called relate. Like that. And then we're going to import it up here. And then we're going to use it in the test. So we're going to relate dogs, our owners, dogs, and ownerships. Call that the result. And then we need to say what it should look like when we're done. So we'll say something like related, say like owners with relationships. So that should look a lot like owners. Except it should also have the dogs in there. So I own Bixby and Mesa, so I should have both of these. Like that. And then Elise should just have Mesa. Like that. And so I should expect result to equal owners with relationships. Cool. We can do it from the other side also, but this will get us started. So if I npm test, cool. I expected this back from it, but I actually got back undefined because nothing happens in the function right now. So your task is going to be to fill out this relate with let's see, owners, dogs, ownerships, and it returns what? Neat. Questions? All right, pushing this up. Cool, it's in chat. Fork it, clone it, work the problem. Let's take a little bit of time. If you're relatively new to Node, after you bring that down, you have to npm install. That's going to bring in all the dependencies. And then running npm test will run your tests. If you want it to run continuously, you can do that too. The npx just watch all.
What are we typing for test again? Oh, I see it on the right. Never mind. Thanks.
By the way, this was, I think it's more fun if you don't know the context. This is from an actual training that I had to do as a Flatiron employee. I just love that graphic so much.
The power of coffee.
Gah!
Everyone's doing pickup right now. And their computers were down.
Just ran across this graphic from my archives.
Yes, I yeah.
All right, gang, let's do a fist of 5. So fist is, I don't know what we're supposed to be doing. 5 is, I got the transformation. Ooh, we got a pretty big range here. So let's talk about it some. All right, so if I NPM test, I get some failing tests. Cool. How about I keep those running? All right, so if I did something like just returned the owners directly, now it's saying I have everything except the dogs part. Cool, like that's what I'm looking for, right? So now I need a way to find which dogs are mine. So maybe I do something like owners.dogs is an empty array, or I could say owners.dogs is all the dogs, and I return the owners. Let's see what that does. Let's see. Getting there. So, but it's not all dogs. For every one of the owners, it's going to be slightly different dogs, right? So I need something like owners.map, because it's transformation, right? I'm going to have every individual owner, except every individual owner is going to be a little different. So if I do something like owner.dogs is an empty array. Oop, didn't like something that got back. Let's take a look at the spec. Oh, I have to return the owner. Duh. All right, cool. So now it's getting back this empty array, but it's expecting array that's full of stuff. All right. So maybe another thing that I need in here is only that owner's ownerships. If I say only that owners, what should immediately go off in your head? I have a big list of ownerships. I only want mine. What kind of transformation is that?
Find or filter?
Almost. Find's going to find the first match. I want all the matches.
Filter? Or
Filter. There we go. So I can do ownerships.filter, take in an ownership. And then how do I know whether or not I should include that relationship?
If the owner ID matches?
Yeah, matches what?
The actual owner.
Yep. Because I'm mapping through these. So if that one's me, that right there should give me my ownerships. Okay. I can probably one line that too. All right, so I have my ownerships. So then with those ownerships, what do I need out of those ownership records? Remember, an ownership looks like this. So if I'm on Kyle, I got back these two objects. What do I actually want?
The dog ID?
The dog IDs. So if I have an array of ownership objects and I want an array that's the same length but only pulls one thing out of it, what kind of transformation is that?
Is that a for each?
Almost. So for each is something with side effects. That's what we use eaches for. This is an actual transformation. I have these two things back. I want an array with 1 and 2 in it, the matching dog IDs.
Mm.
Find all.
Not find all,
It's just a map?
just a map. It's a
Oh,
transformation. An array of 2 objects, I want an array of 2 numbers. It's an array of 2 things that were in those objects. That's just a map. So I could say my dog IDs is my ownerships dot map my ownership dot dog ID. Okay. And then if I have an array with 1 and 2, how do I turn each of those into the actual dog object? What would I do to get my dogs?
Would you? I'm tied between. It would be filter, right? You would filter over your dogs array to match that ID. Like if that ID matched that specific number.
Ooh, that wasn't what I was thinking, but that'll work. That'll totally work.
What were you thinking?
So I was thinking we can transform those IDs into the dogs. That's a map. Your way works too, though. Let's do that. So my dogs would be all of the dogs filtered by what?
The dog ID triple equals. We're going with. Is it 1 or 2?
Ooh,
Or do-
interesting.
Oh.
Triple equals. Remember, dog IDs. So for the first owner, I have an array with 1 and 2 in it. Triple equals, that's going to be like, is it the exact same array? Actually need another applicative. It's one we don't use a ton of, but use a little bit more in Mod 1. Includes. My dog IDs dot includes this dog ID. So I go through each dog. I go, all right, ID 1. Was ID 1 in this array? It is. Cool. Give me that one. Was ID 2 in this array? It was. Cool. Was ID 3 in this array? It wasn't. Don't keep it. So now I've got my dogs. Real quick pivot. I like this. There's some efficiency problems with this though. Can anybody tell me what the performance issue of this approach would be? Has to do with how filters work. Filter's going to go through every single one of the dogs every single time. It's not a big deal. There's 2 dogs. There's 2 million dogs. Hey. So we can make that a little, we can take that from an O of n to an O of log n if we're finding the dogs. So if we say, all right, I want to take each of these, and for every one of them, I want to find the dog, because then those stop as soon as they find a match. So assuming that the dogs are like, the dogs you need aren't all at the very end of the list, some of them will get quickly, some of them will take a long time. We'll probably average out to about log n. Another way we could do that is if we turned the dogs from an array into an object where the keys are their IDs, that's O of 1. It always takes the exact same amount of time to look up the value of a key on an object, no matter how many of them there are. Got some options. All right. So now, if I said owner.dogs equals my dogs, I got a passing test. I can clean this code up a little bit more. Those of you who are familiar with my cross-canceling kind of thing. All right, I see that there, and I see that there. That means that I could chain those together. Anybody remember Y? It starts with an R. We talked about it a lot last week.
Referential transparency.
Hey, since my ownerships is equal to this line of code, that means I can replace my ownerships with that line of code. If I put this on some new lines, I'm kind of describing what's happening there. Not fucking bad. Same thing with my dogs. If I did, so I've got that there and that there. So if my dogs is equal to that, that means I can swap it out. All right, that's starting to get a little bit better. And lastly, let's say I did it the other way with a map. I could map off of that. So I have a dog ID. And what I want from this is dogs.find dog ID. Well, shoot, now I can chain it right off of that one. So now that's more like my dogs. Oop. One is not a function. Did something wrong. See why it's mad at me. At array.find. Dogs. On line 6, at array.find. Oh, array.find takes a function. So it's going to be dog ID equals dog ID. Or I'm in JavaScript. You can camel case that. All right, still passing. So I've gotten all of those. So I have my dogs. All right, well, I can kind of cross cancel that, can't I? If I said, that's my dogs and that's my dogs, well, then I could really do owner.dogs equals that whole chain. Still passing. Nice. Now the like functional programmer in me wants to know if there's a way that I can get rid of that statement. Because I have this statement and this statement. I want to see if I can get that down to one statement. You totally can. This is what like object spreading is for. So instead of that, we return a new object that spreads owner and then also has an object with dogs, which is this whole big ass chain here. Still pass? Nope, broke something. Turn unexpected token on 5. Oh, I think it's just this. Yep, passing. Ah, shit. One statement. So we took an array of owner objects, an array of dog objects, and an array of ownership objects, and we wrote a function that takes all those, jams them all together, and gives us this beautiful many-to-many that we got for free with active record includes and whatever else. But should you find yourself in a situation where you have to do all that by hand, that's what it would look like. Ask me some questions about this. This is heavy.
I'm just looking into Node backends, but is it where you have to write all the logic for the backend, like resources?
Yeah, more or less. I mean, this isn't even Express. We're not serving this up from a web thing at all. Node is just JavaScript on, but like you don't have to run it in a browser. So we have this like module system here so we can import and export files. But past that, nothing I did here, like you're not allowed to do in the browser or anything. There just isn't a browser that it has to run in. If I wanted to serve this up from a web server, I can install Express. I can include it. Could do something like app dot. If you make an HTTP request to the root, then you can respond back with owners is actually to do that. I do need this data. So shoot, I can even separate out that data from how I'm using it right now. We can do something like touch data.js. Then I can module.exports owners, dogs, and ownerships. Now over here, I can import those in. Owners, dogs, ownerships. Do the same thing over here. So it helps if I spell it right. And then I can use that function that I just made. Probably make more sense to put this on like an ownerships endpoint or owners. Cool. And tell it to listen on some port and run it. Oop, because it's in the same folder as this one. All right. If I go over to localhost 4000, it tells me that I can't get root. What's it mad about?
Dash owners.
Owners. There we go. Thank you. There's my many-to-many relationship, but on the web.
What is the owners doing?
It's called a spread. So what it does is it's just like I took all of the stuff in this owner object and this is probably the easiest way to think of it. It's just like you took off the curly braces from it. So if owner is like that, spreading that object is like that. So if you look at that, that's going to be that owner object. That's just like I copy and pasted that in there. It's really handy for exactly how I'm using it right here. I want to jam it together with another object. So what I do is I make a third object, spread that one, and then add whatever other properties that I want. You can also overwrite properties this way really easily. It's a cheap way to make a copy of an object. There's a couple reasons you might use it. Spread is what that operator is called.
I've used that a couple of times with React, but I've never known it. You could use it like that.
Yeah, so you use this all the time with arrays. But yeah, you can also do it with objects, and it works the exact same way.
And how would this be different with objection?
With objection, I would have like it works the same way it would with active record. I would make an owner model. I would make a dog model. I would declare their relationship, and then I'd do something like owner.all with graph fetched dogs, and then I'd be done. Which would be like, it's the same thing in active record as dog.all includes, or owner.all include dogs.
So wait, is objection like the OOP version of this?
Objection is the active record version of this. This is what objection's doing under the hood, is like stuff like this. This is how you would build an object relational mapper. It's way worth your time getting solid and fast with data transformations. It's such a bread and butter thing you do as a developer. It's like in your day job, when you're not learning fun new things all the time, like what you're doing the rest of the time is data transformations. Taking data from one format, taking a whole bunch of different kinds of data, smushing them together, summarizing them, filtering them, cleaning them up. Like that's bread and butter programming work. So like it's worth your while to invest some time getting really fast at this kind of stuff, but don't do your own object relational mapping. Hopefully this convinced you to not. just use an ORM.
I'm definitely going back to objection.
Mission accomplished.
Would we need to ask for like, is it hard to link this back end to a front end?
No, not at all. Like this. So right now, when I do that, that's served up here. Fetch localhost 4000/owners. And now you too have this object.
Oh, okay. So we
That's
would
it.
just use this in our front end. Oh, okay. Then okay, I don't need a class on that.
Same way you would every other API. But whereas like Rails is 4 billion files and that crazy boilerplate file structure and stuff, this is 28 lines of code. And a giant node modules folder. There's plenty of like stuff other people wrote for this, but the code that we had to write is small. On the other hand, if you want anything, you have to add it in yourself, you need to write it yourself. It's a very manual approach to doing APIs compared to something like Rails where you get everything for free. And there are situations where like that's appealing and other situations where it's not. All right, one last thing. Anybody, how would I make this like this only works with dogs and owners right now. It's unfortunate. They know how I could make this more generic so it could work with any two tables, because like I've actually written in dogs and owner ID and dog ID. Any guesses how I could make that more generic?
Can you just switch them to key and value?
It needs to be a specific key and value though.
You turn each of those filter map into their own functions.
Totally could. So like, actually, let me do this. This has nothing to do really with the lesson. This is more of like an extension of the functional programming stuff that we did last week. So if you want to bounce and go to lunch, have at. This is how we might. So let's do that. Let's make these their own functions. So something like function owner ID. Only my owner ID. So it takes in an owner, or say is my owner ID. Takes in an owner and returns whether or not is my ownership ID, sorry. It takes in an ownership and returns whether or not that ownership's owner ID equals an owner ID. That's a little rough. I need to replace this function, the little arrow function here, with this, but I need two different things to make that work. Anybody know how I get around this? This is like opening the door to functional programming. Filter takes a function that takes exactly one argument. It's going to take in whatever that ownership is, but needs a function that it can call with that. Yet it also needs that owner object. How can I do both of those? So what it ultimately needs is a function that it can pass in an ownership to. Cool. But if this is a function that takes in an owner and it returns a function that takes in an ownership, now it has both of them. And don't let like the arrow syntax there fool you. You could also write that same thing as this. Function that returns a function. First time you call it, you pass it in with this. Second time you call it, it gets called with that. Has access to both of them. Like that. So now that filter can get replaced with, is my ownership ID owner? I invoke it. The thing that it returns is a function. Fucking wild. See, this one a little easier. This would be like get dog ID, takes in an ownership and returns ownership dot dog ID. And then that becomes get dog ID. Now, if you look at how this function's written though, that doesn't have to be an ownership. Any object that has a dog ID you can get. So that could just be object. Get a dog ID out of an object that has one. Okay. But if it's doing that, would it be useful if I could maybe get any key out of an object? So what if that were more like object key, and that were something like object at key, and you called it with like get dog ID and then some object dog ID like that. That would be kind of nice. But zoinks, we're still in that problem where map is going to call a function with exactly one argument. So we can do the same thing. We can just call it get that takes in a key and returns a function that takes in an object and returns object at key. So then that becomes get dog ID. Are you starting to see how like functional programming lets us solve problems very generically, very mathematically, and all these like kinds of cool reusable ways? All right. Let's take a look at this one. So this is like get dog, something like that. Takes in a dog ID and returns something like that. Oop, but it needs dogs too. So I could say something like, we'll also give it dogs. Fuck, then I'm in the exact same position that I was with all the other ones. And so I do the exact same thing. Do something like get dog, takes in dogs first, and then returns something that gets called with a particular dog ID. Now I can do dogs.find dog. Dog ID is dog ID. And this one becomes something like get dog, all the dogs, and then it's going to have a function it can call with that ID. Okay. Now, really, this function, this is also pretty generic. It's not really get dog, could, but really this is like, takes in some array, it gets in some ID, it looks through the array, finds an object where the object's ID matches the ID. So really that's like find by ID. Generic, reusable, composable.
So with that, that means you can reverse it. You can find the owners of the dogs now.
With the exact same code. This one. All right, so if we're trying to make this generic, this works to an extent. I can say like object, object, object. Oops. So owner is object. This is like related object. Owner ID though. That's like very specific to my problem. It's gonna be a problem. Or is it? So I can make this something that's like, is my related ID if I take in the key. And make this, it returns something that takes in an object, something like that. Interesting. So now is my ownership ID, I could do something like is my related ID. It's going to take in the key that I need to look up, which was owner ID. Like that. And now this one can be generic as hell. Okay. So now all of the actual work, none of this is specific to like dogs and owners. It'll work with any many-to-many relationship. The only hints left that those things still matter are this string and that. All the rest of it I can make pretty generic. I could call this table 1, that was owners. Table 1. We call this table 2, that was dogs. Something like that. This one is going to be like table 1 object instead of owner. Table 1 object is owner. Table 1 object. And then ownerships is going to turn into like join table. So that one's join table. Cool. The only things that I have left that are specific to my problem, dogs, like that, that name there, and then these 2 IDs. Everything else is generic. Okay. So what if that same trick there? You'd make this relate, and it takes in table 1 key, table 2 key, and then relationship name. And I return that. Like that. Okay. So now to use this, I'm going to call it with table 1 key. I call it with table 2 key. And then this one, this is like black magic, and it's pretty new in JavaScript. But you can do a variable key name with like that. Wild. Now, so it's owner ID, dogs. Result becomes owner ID, dog ID, dogs, and then I pass those things in. Is there any fucking chance that this still works? It's mad about something. Unhandled error. Oh, I'm already using 4,000 somewhere. I'm gonna get rid of all the express stuff. Relate is not a function. Oh, it's not being exported anymore. Module.exports. Relate. Passes. So last thing, and then I'll let you eat. I've made this totally generic solution to this problem. No dogs or ownerships mentioned. That means I should be able to do it the other way, right? I do dogs with relationships. Dogs with relationships. That's the name of my NBC sitcom. So I take in dogs, and they have owners. And Bixby is owned by Kyle and Elise. like so. And Mesa is, or no, sorry, I did that wrong. Kyle only is both on Mesa. Only Kyle owns Bixby. All right, so that's what this should look like if we do it with dogs. Can I write a test for that? Great. Dog ID to owner ID with owners, with dogs, owners, and, oh, actually, I'd pass them in the same order, I think. And the result should equal dogs with relationships. Oops, I'm wrong. Maybe I did have to flip those around. Dogs, owners, ownerships. Works. Generic programming. When you're doing data transformations, that's what you're shooting for. I really don't use functional programming a lot outside of this kind of stuff. But like I said, it's such bread and butter work. It pays to get fast at that. And if you think about, like, if you were writing this with for loops and if statements, which you totally can, it would A, be 30 times as long, and B, the number of places you could make a mistake and never notice it, hundreds.
So to like abstract these, you can just import and export these functions to use on different things.
Correct. Yeah, I can tuck this away in a relate.js file and import it anywhere I want to use it. And like, to bring it back to paradigms, the data is completely separate from the behavior, the state. State and behavior have nothing to do with each other in this. All I've done is to describe the behavior, and it'll work with any state. That's the functional paradigm versus OOP. This is, by the way, this is exactly what you did, and this is the Mod 1 Code Challenge. That was the OOP version of it. I create a new instance of this relationship, and then the join thing keeps track of every single instance of that, and then I iterate through them and get only mine, and then I map those to just the dogs, and then I get rid of all the unique stuff. This is all of that functionally. Other questions? Have a good lunch.
Thanks, Kyle.
You're very welcome.